Okay, hello again, I'm Szczepan. I'm a core developer at Gradle, and I guess I'm the best person to talk about Gradle in large projects, because for the past couple of releases, those hands were adding features to enable Gradle for better scalability. Well, obviously, the features were designed by the entire team, but I was the one to develop them. I also lead the Mockito efforts. Anyone uses Mockito? Very good. You make me happy today. Excellent. Thank you. And I live 3 blocks away, around the corner, in Krakow, Poland. Hang on. My phone is... OK, there you go. OK, so I just made up these stats to get us in the right context. What is the large project and what is a small project? And I guess a small Gradle project is something less than 10 submodules. And I wonder how many of you fit into those groups. So who has small Gradle projects? OK. OK. Who has medium Gradle projects? OK, most of you. Excellent. Who has large Gradle projects? Oh, God. OK. And very large projects? Oh, I was hoping there's going to be one hand only. Gigantic project. One hand, please. OK, 2 hands. All right. All right, because that's the LinkedIn contingent. OK, got it. So I will discuss very large projects in this presentation. So various features of Gradle and various tweaks you can do and your approach to building Gradle scripts so that it's going to scale better. However, I do believe that very large projects and gigantic projects are not the regular case. I would say they are more like edge cases scenarios. So typically, you divide and conquer, right? You modularize your application in the fashion that you are not you don't have that large projects or that gigantic projects. However, life goes on. Sometimes, because of legacy reasons, because of the various other reasons, you might be faced with a gigantic project or a large project, and then we have to deal with that. Okay. So there's one best advice regarding the very large projects. Don't have them. Now, but as we mentioned, we have some of the large projects, so let's try to find a solution. Few words about our competition. So in Ant deals perfectly with very large projects because it does not have any model, any rich model. So let's skip that. However, Gradle and Maven, they do have a model. So in Gradle, you have projects, you have dependencies, you have tasks, right? Maven also has a model. So I would say that both those tools may hit some scalability border limits. And at Gradle, I would say it's around 2,000 projects at this stage. Not sure what's the case for Maven, but I guess it will be probably similar. So anyone has been with a gigantic Maven project? Like how many modules? How many modules? 250. How did it work?
It was slow, particularly in the IDE because it was a monolithic project.
Okay. So we have a 250 module Maven build, and there were some problems, but yeah. And I guess Gradle or Maven, they would both will be not working very well for like a gigantic project with order of magnitude projects at the level of thousands. Now, we are adding features to Gradle to enable scalability. Our vision is that Gradle just scales, period. So whatever large your multi-project is, we're going to scale to that. You just need to add some more. You just need to add some more hardware, for example, more RAM, etc. But not that much RAM that is needed right now for the 2000 project build. OK, so really small things you can do to make your large project experience better. So definitely use the wrapper, because in large project, troubleshooting problems with large projects are inherently more time-consuming, right? The Hello World build application is very easy to debug. 100 module Gradle build, when it fails, is not as easy to debug. So wrapper gives you consistency. You basically use this. Everyone in the team uses the same Gradle version. So basically, one problem that you might have, that someone is using not the right version of Gradle, this problem is away. Therefore, troubleshooting easier. One of my friends from the company that I worked several years ago, he was like a Maven legend in his organization, and what he did is basically he often had he was lucky to find solutions for problems that people spent hours on. So people are spending like few hours figuring out what's the problem, why this Maven build fails, and then he just walks around and says, check Maven version, and then boom, and that was the solution, right? So, so the problem with Maven was that there was the time where the Maven version got upgraded, and some people started using newer version, and the build was failing. But the build didn't tell that, hey, you are using wrong Gradle version. The build just said error, and they had to figure it out. So with the wrapper, we make sure that the version of Gradle used by the entire team is consistent, which is a very cool thing. There are ways to do it in Maven as well. Yeah, but in Gradle, it's like more default approach, I would say, so that everyone uses the wrapper, and you should do. Okay, another thing is using the daemon, all right? So in theory, daemon gives most benefits for like smaller builds because it makes the startup of Gradle faster. Let me rewind back. So the daemon is a Gradle process that sticks around even after the execution of the build. So basically, it's a long-lived process who is in the background, and basically every time you invoke Gradle builds, it connects to that daemon and instruct it to run the build. Therefore, you can take advantage of some caching, and you don't pay the cost of the JVM startup. So, daemon is excellent for like a small, fast task invocations because they are really, really snappy. However, in very large projects, it appears that it's also useful for any kinds of basically invocation. So for like long builds, it's also very useful. And it will be even more useful in future as we're going to be adding more and more features to daemon. So the benefits of the daemon will be more than just the JVM startup and some of the JVM optimization. Daemon will be active. For example, it may perform some up-to-date checks. It may rebuild the model of Gradle so that next time you run a Gradle build, you don't pay the cost of configuring all the project at all because they are already configured and hot, and daemon keeps them so that you can just use them. So this is those features that we plan to add to the daemon. They are tricky because we need to find a good way to invalidate the model if it changes. So they are not going to be easy to implement. But nevertheless, just keep in mind that using the daemon is the way to go, because it is faster now, and it's going to be even faster soon. Any questions you might have?
When you say you use daemon, is it also for the continuous integration server, or mainly for the developer workstations?
I would say that the daemon, I would use daemon mainly for the dev environment, because it's much easier for a developer to manage this extra process, right? You can just kill all Java, no daemons, right? Whereas if it's on the CI box, then well, there's some extra process that it needs to maintain, right? I mean, at some point in future, we might add some ways to manage those processes in some nice way. Therefore, you would, for example, know how many daemons are there on your Linux box. But I say that for now, I would rather avoid having this extra process on the CI box, especially as the CI box, it feels that it does not have to be like super fast, right? It's like it's important that the dev cycles are as quick as possible, so that the build is snappy for the developer. But the CI box that does not take developers' resources and just runs somewhere there, whether it takes 10 minutes or 5 minutes, it does not make that much of a difference. That's, let's say, my recommendation. Yeah, Jens?
So I understand your recommendation.
Okay.
We will not be following it, so we will figure out how to do the daemon CI for sure.
Okay.
Because there's 5 minutes versus 10 minutes is a big difference to us.
Okay.
It makes
I mean, cool. So Jens is from LinkedIn, and we will be using daemon on the CI boxes at LinkedIn. So I'm really happy. It's because it'll push daemon harder, and we will make sure that daemon is configurable to the point that it's useful at the CI box. Right now, for example, the daemon expires after 3 hours of being idle. And let's see whether this is a good number for like a CI box. It feels for us it's a good number for a developer box because even if it's too big time for you, you can just kill the daemon, right? So yeah, I mean, sounds good. I'm on it.
Can that be configured today, or is that just hardcode?
It can be configured, but the property that configures that is not really public, so it's not documented. But it's if you use it, I don't think it'll go away, because it's important. We use it for our own testing infrastructure, where we run stress tests for the daemon. We need to control how long they live. Otherwise, our CI box will have, for example, 100 daemons after the execution of the build. Because like on our CI boxes, we run Gradle with different. We run integration tests against different Gradle versions. Let's say 20 different Gradle versions. Daemon is compatible with the given Gradle version, which means that if on your local box you run Gradle builds with various Gradle versions, let's say you have multiple projects, one project uses Gradle 1.6, one 1.5, the other one 1.3, and you are all running with the daemon, all of them, you might have 3 daemons, every daemon for a specific Gradle version. So therefore, we needed a way to control the expiration date of the daemon, because otherwise we would have zillions of daemons on our CI boxes, and that wouldn't be very helpful.
So we would likely need no expiration.
No expiration. I mean, what we can do at some point is we could make the daemon restart after a certain period of time. For example.
Yeah, I mean, I don't care too much about
Yeah,
how and I
but
think
it's there. It's waiting for you. That's the goal,
I think
right?
that's a good idea, actually, to have it recycle
Yeah.
once every period.
Because of it's like with every Java application, right? You need to restart it at some point, right? And it's like it has been like that 15 years ago. It is like that now. So I mean, it's we might do something like that, right? So we could even add more smartness so that the daemon can understand how much memory it consumed, and if it's above certain threshold, he just restarts himself. So those things like that. We could monitor the speeds of the build, right? And if for some reason the next invocations of the build against that daemon are slower for some reason, we assume that something's going wrong, let's restart it. I mean, that's up in the air. We haven't yet decided, but those are general ideas how to make the daemon experience even better. Yep, sure.
What daemon currently cache?
What?
Only the project configuration.
Okay, so the daemon at the moment, the simple answer is it does not cache anything, let's say. It only let's say the JVM is already started and Groovy runtime is already loaded. But that's not entirely true. There are certain objects in the Gradle model that are, I'm not going to call it static, because they are not static. They are kind of global for a particular Gradle process. And they are basically, and when you kick off the daemon, those classes, those services, they are instantiated. And then after the build, they are still alive, right? So the next time you run the build. So there is some caching there. However, I wouldn't say that it adds a lot to the snappiness of the build. But it will do more caching. I'll go back to that later as well. Any other questions? Okay. So, okay, and one other thing you can do when you have large projects, use Gradle 1.7. I know that 1.7 hasn't been yet released, but feel free to try out with the Gradle nightly. Definitely try out the release candidate and let us know how the improvements that we've done work for you. From the highlights of the performance improvements we've added to Gradle 1.7. So caching of the dependency metadata. So traditionally, Gradle, when the configuration was resolved and the dependencies are being resolved, we basically read the IV descriptor directly from the disk. And basically, if the same dependency appears again in some other configuration, we read this IV descriptor from the disk. And this is, in various ways, is inefficient. For example, if you have a compiled dependency to the log4j, let's say, and you have a typical Java project, then we read the log4j IV file 4 times for the compile configuration, for the runtime configuration, for the test compile, and for the test runtime, provided that you have some tests. So you can see that like in a very large build, dependencies are often the same, right? You have like a multi-project structure, right? You have Log4j is a dependency to one project, but then this project is consumed in others. So it's like Log4j can be loaded, let's say, 500 times during the build. And in very large projects, this appeared to be a really nice thing to tackle. It appeared to be a bottleneck. So what we've done, we've started caching those dependency metadata in memory, which means that first time this IV descriptor was loaded, it's going to be, the next time someone needs this dependency, it's going to be reused. And this is like just reasonable thing to do. I mean, you would expect that to be like that, you know, from Gradle 1.0, I guess. But it wasn't, and in 1.7 it is. Interestingly enough, we keep those metadata information in memory. You might think that, wow, so the heap size is going to go high. Well, it's actually the opposite. So the heap size went down after this feature because of the fact that IV is pretty, well, the code is not really nice. So with all due respect, it's a useful library, but there are like, there's so much static state. Like if you instantiate one object, it just hooks up to like everything in the entire world. So it's like those objects were heavyweight. So every descriptor that was loaded was pretty heavyweight. So caching them actually improved the heap size, lowered the heap consumptions of Gradle. Unless I'm wrong and something else we've done in 1.7 actually improved the heap consumption. But there's also a possibility of that. However, like that would, yeah. Okay. So any questions you might have for caching of the dependency descriptors? No. One other interesting thing about those caching of this metadata is that it's slightly breaking change, let's say, because you might have a scenario where a dependency changes during the build, and you basically your build relies on this ability. Now it's no longer possible. This dependency will be loaded once. But we thought about it deeply, and we don't think that there are reasonable use cases for that scenario. We believe that within the one build, you know, one dependency with one version should be just loaded once and accessed once. That's like, however, hang on a sec. We want your feedback. So if you try out with 1.7, if we have use cases where within the scope of one build, you want to have the same dependency with different versions loaded, let us know. Maybe this is something we are missing.